There is, as long as it's not a high burn severity. Yes, there is mineralization that does occur. Great questions. Oh, go ahead.
So the hyphae in a deciduous, where there's deciduous trees, when the leaf fall happens, you can see the hyphae digesting the leaves. But in the forest, I've never quite seen that. And if you masticate it or chip, would that, if it does happen, would they work in that kind of a situation?
Oh, that's a good question. I think that probably has more to deal with soil pH and other factors, probably more so than what the actual woody biomass is. I think there's probably some other factors at play there. And I would assume, and I'm not a mycologist, but I would assume that the fungal hyphae that populates a hardwood deciduous forest versus a conifer forest, I think there would be two different types of fungal hyphae, because you tend to get more acidic conditions under a forest degree, like conifer environment, than you would a deciduous forest environment. So that's probably at play there with that. Okay, questions? So I'll move on from the mollisol soil type with conifer encroachment on that and what that mollisol soil type has told us. We'll move on here. This is just a reminder of the distribution of unique andisols are versus the mollisols, because we're going to talk about andisols and why they matter. So the volcanic ash cap soils, the soil taxonomic designation for a volcanic ash cap soil is 18 inches or greater. They're generally unique to the Pacific Northwest and the lower 48, although they do exist in Hawaii, Alaska, around the Pacific Rim of Fire. Up here in our country, we were kind of blessed by a geologic stroke of good luck that we had a series of volcanic events after the ice sheet melted. They were dominated by Glacier Peak eruptions, Mount St. Helens, and to a lesser degree, Mount Mazama, where Crater Lake, Oregon is. That ash really doesn't influence us too much here. We have a little bit of it, but it's been buried by Glacier Peak and Mount St. Helens ash. Right here, the white ash right there, that's 1800s Mount St. Helens. And right here is Glacier Peak about 400 years ago. And the difference in the two, the color right here, the iron and the manganese is starting to weather out. You can think of it as rusting out of the soil. And right here, there just simply hasn't been enough time, one of those 5 soil forming factors, to start weathering that iron and manganese out of that ash. So it's pretty cool. I found that by sheer luck. That's a really good picture. And then around here, what I've found, you can have plant communities kind of tell you what's below ground. Right there, that's a prince's pine, like the prince's pine. Anytime you see that in the forest, you're going to have volcanic ash under that because it's water demanding and it needs a lot of nutrients. And that's associated with volcanic ash cap soils here. You won't see that in glacial till. So that could be a little indicator. And I didn't do that on purpose. I just seen that out. It worked out pretty good. So some unique things with volcanic ash cap. They have very high water holding capacity that is not ionic bonding, and that's very important. Water, H2O, is a dipole. That means it's slightly negative and slightly positive charged. And if you have high clay soils, that clay is slightly negative, so the positive side of the water molecule ionically binds to that, and it's really hard for plants to pull that off. Whereas in volcanic ash cap soils, this is magnified from 30 microns. What does that look like? It looks like a sponge, right? And all those water molecules just reside right in those little pore spaces. Roots start coming along, they can grab it and take it out. It's not ionic bonded to that volcanic ash. That's what makes this ash cap soil so productive. And over time, we have nutrient stores that start to weather out of the volcanic ash. We call them short-range order minerals. So that helps with the fertility as well. And then to connect that interdisciplinary approach to land management, these are soils where we can grow big trees over time. Say if we were to go to back to the slide with the mollisols, so I cored all these Doug firs here, and they're not that big a DBH. And they're like 80-year-old trees there. They got mistletoe in them. They're diseased. They're just not healthy. It's just not something that's going to be sustainable over time. But these ash cap soils, that's where we're going to have those big trees that support habitat for our key indicator species like pileated woodpecker and goshawk, particularly for Mount Hall. So that's kind of connecting that interdisciplinary loop with that. And wildlife biologists thought that was pretty cool. So I broke down a lot of misconceptions of how to use soil science and soil mapping knowledge in the planning process through this, because a lot of people just view it, well, it's just dirt, so all you do is you come in and you give us the soil BMPs that keeps it productive and will be within our forest plan standards, and just do that, but when I show them that we can actually have management treatments based on soil types, it opened some eyes, and it was really cool. It's taken a few years to get here, but we're here. I think when the draft EA comes out, I hope you'll take a look at it, because I really think we have a really good holistic project up there. I think it's something that the public here is going to be really happy with too.
Luke, I understood that the Northwest Forest Collaborative was majorly involved in this project.
Mm-hmm.
That must have been a bit of a convincing project to them too.
It's funny you say that, George. Thanks for bringing that up. The Northwest Forest Health Collaborative hired Derek Churchill. He's with University of Washington. He's now with DNR. He does a lot of ecological modeling. And the models that they were using for Mount Hall were just all wacky, because we're in Okanagan Highlands. It's kind of a grass-dominated environment. We have this really unique landscape in that broader grassland that's Mount Hall. And their departure analysis just wasn't working. And the reason why it wasn't working, because it was centered around forested environments. And the Mount Hall runs kept kicking out, well, it's grassland. And it was an error category that they just couldn't compute because it wasn't a forested type. So I'm sitting here listening to that, and I'm like, hey, I got an approach that could fix that. And so thanks for bringing that up. And that was the antithesis of this. And I started talking and showing Derek Churchill this, and then he kind of incorporated some of this into the departure analysis, and it reduced a lot of the model noise by incorporating this approach. So it was pretty cool that way. So thanks for bringing that up, George. Any other questions about volcanic ash cap soils? These are great soils. They're actually, did you know that all 50 states have state soil? It's true. Our state soil is a volcanic ash cap soil around the Puget Sound. So. And so the last unique soil type that I'll talk about tonight are hydric soil types, better known as wetlands. They have the ability to store water on the landscape longer into the year. That's very important for groundwater recharge, for cold water discharge into our streams, for fish habitat and aquatic organisms. It's a lot of areas where we have unique plant species, a lot of unique animal species, and just really unique features along the landscape, and they can act as fire breaks as well. In this particular instance, this is a wetland soil, the hydric soil, and if you remember a few slides back of remembering water saturation, so that was blue, and this has been in the sun for probably about 30 minutes, and if I let it dry out, you would see that red modeling down here, and that would be remembering water saturation. This is beautiful thatch macrotch. It's a beautiful soil profile in general. So when so I'm geeking out on you guys. So part of when you remove fire, even from wetlands, because wetlands will carry fire later in the year when they dry out a little bit. But when you remove that, you start getting some conifer encroachment into your wetlands too, and that does draw down the water table and things like that. So we're looking at doing a little bit of conifer removal in here. We're leaving the big stuff, because out here we actually found a great gray too. It was pretty cool. So it's just another cog in the wheel of having that holistic restoration approach on the landscape. You know, we're not going to places where it's just murk timber that's high value and that's where we're going. You know, we're going places that matter and they're ecologically meaningful. And we have used a lot of different interdisciplinary approaches to get there in this project. It's been really neat. A great journey along the way.
That's a
Great gray owl. Maybe you've seen the great gray owls with the black eyes. They're really cool owls. They're pretty neat.